Good afternoon. This is the second day. AICTE AQIS sponsored STTP PHASE-3. The program is started here, and our honorable resource person, Lakshmi B. Ranavan Vare, today afternoon session demo on NLP for Indian languages. So from Professor School of Computing and Information Technology, Reva University, Bangalore. So I am handovering the session to the madam. Madam, please take over the session. Madam, please take over the session. Please take over the session, madam. Is there, madam?
Hello?
Yes, madam. Please take over the session, madam.
Are you able to hear me, sir?
Yeah, I'm able to hear. You start the session, madam.
Okay, sir. Okay, so we are going to see the hands-on session on natural language processing. In this, we are going to see the techniques, whatever we have discussed in the morning. So the first one is bag of words. Then we are going to see hands-on on TF-IDF, then word to vector, then text frequency analysis, semantic analysis, then web scraping, and then the total how we are going to create a data pipeline for text analysis. So this is the agenda for this afternoon session. And let us see the first one. As we know that bag of words, why we, it is the text information we are going to represent in a vector form using this technique. And also we know that there are two things whenever you are going to analyze data. The data can be numeric or data can be text. And the famous statistical algorithms such as machine learning techniques or deep learning techniques, these only work on numeric data. And it is not possible to, these algorithms will not process on the unstructured data. Unstructured data means text data. So numeric data is a structured data, whereas text data is also called unstructured data. So these unstructured data or the text data on which these statistical algorithm will not work. Okay, so as we know that there are two statistical algorithms. One is machine learning techniques and another one is deep learning techniques. And these algorithms will not work on unstructured data. Now, how we can, when we want to make use of this machine to learn about the information which is in the form of text, then we have to convert this text data in some vector format. Okay. So one of that technique we are going to see the common methods which are used are bag of words, then TF-IDF and word to vector. These are the three methods we are going to have for converting this unstructured data to structured data. So bag of words, it creates a vocabulary of all unique words in a document. And it is a collection to represent a sentence with a word count, how many times a particular word is appearing in that sentence. So this is the information which will be there for the bag of words. Now, when we create a bag of words, what we are going to do is we are going to take the input, which is a text, and then we are going to clean the text. What is text cleaning is, if it is having some special characters or some emojis or some other characters, if it is other than the characters and numbers, if it is other than these two things, then we are going to clean the text. So that is called text cleaning. And so that process we are going to do in bag of words. And then we are going to tokenize the text. That means we are going to divide the text into tokens. So tokens, maybe if the document is very large, then we are going to divide the document into sentences. That is called sentence tokenization. And if the document is very small, like sentence, then the sentence is divided into words, and that is called word tokenization. And after tokenization, we are going to build a vocabulary. So building a vocabulary, in the sense, it is a creating a dictionary. So we are going to see this is also called feature extraction. So build vocabulary or dictionary building we are going to perform. And then we are going to create the vector. So we are going to generate the vector. So these are the process we have to do for bag of words. Now, let us see the theory behind this bag of words approach. Let us consider we have three sentences. I like to play football. This is the first sentence. Then, did you go outside to play tennis? And John and I play tennis. So these are the three sentences. And when we have this, then the first sentence is divided into tokens or individual words in this way. Second token sentence will have these words, and the third will have these tokens. Okay, so when you want to create a bag of words, then the next step is to create a dictionary. So the word, how many unique words are present in this corpus that we are going to have. So I like to play football. Did you go outside? Tennis, John and I. These are the unique words, and that forms the bag of words. And how many times a particular word is appearing, that we are going to have. So I has appeared twice in this document. Like has appeared only once. To has appeared twice. Play has appeared thrice. Okay, and so on. So this is what the dictionary is to be created. So now once the dictionary is created, actually what is this dictionary? It is all the unique words. So those unique words are the features, and these features we are going to create using these features we are going to create a matrix. So how this matrix, what is the columns and rows we are going to have in this matrix? The columns, the column header or column headings are columns are the unique words or the dictionary, whatever we have created. And the rows are the sentences in the corpus. So in this matrix, when you are creating this matrix, if that word is present in that sentence, then we are going to represent that cell is represented as 1. If it is not present, then that cell is represented as 0. Now, if in this case, I like to play football, I should write it as 1. So this is the sentence. In the first sentence, I is there, like is there, to is there, play is there, football is also there, so it should be represented as 1, and so on. Okay, and all other elements should be represented as 0. Similarly, in the second statement, did you like to play outside? So only like to will be 1. Okay, I will be 0. And so on. Wherever the word is appearing in that sentence, that will be represented as 1, and all other cells will be represented as 0. So this is the matrix which is created for bag of words. Okay, the limitation of a bag of words. So what we are going to have is, first we have to create a vocabulary. How many unique words are there? Thereby the size of the columns are going to increase. Okay, so the design, there should be a clear, careful design should be there for this bag of words, because it is going to create as many the sparse matrix also is going to create a lot of entries are zeros, okay, in bag of words. Now, it is very difficult to harder to model such computational reasons, because information reasons, because it is very difficult to have such a large, if the corpus is very big. Okay, and since it gives very minute, we can have only minute information which is stored in a large representational space, because the vector is big, but the information what we are going to extract is very less. Okay, and there are again two more important things which are the limitations of bow is context and meaning. Suppose if you context, because since bag of words is just a collection of words, the order is not there, order is not important in bag of words, and thereby the context, suppose the context of the sentence will be lost, as well as the meaning will be lost. So for example, suppose there are two sentences, this is interesting versus is this interesting. Now when we do this bag of word, both are having the same words, but the context is different. The first statement is telling, it is just assertive statement. Okay, so this is interesting, whereas this is questioning, like is this interesting. Both context is different. One the first statement is just assertive, and second we are asking whether it is interesting or not. So the context will be lost in bag of words. And second one is meaning. Meaning is what, suppose if we write the old bikes versus new bikes, both means the same, but the both meaning is same, but bag of words will have these old and or else you can say used a bike you can take. Okay, so both means the same, both means the same, and old and used bikes means the same, but these two words will be appearing in the vector. And that's why whenever we have the context and meaning will be lost in bag of words technique. Okay, so next technique is word to vector technique. So word to vector technique, wherein we need not have to bother about it retains the semantic meaning. It retains the semantic meaning. So the context information will not be lost. Okay, and the size of the embedding vector will be very small. Okay, so the vector size will be reduced, and we do not need huge spare vectors. We do not have to have a big vector in vector to word to vector spaces. Now let us consider an example for this. That is, word to vector model is a simple neural network based technique. Let us consider an example. King. King is a word, minus men plus women. The word to vector neural network should give the result as queen. And that means meaning, semantic meaning will be, the semantic analysis will be perfect with the word to vector analysis. So word to vector comes in two types. One is continuous bag of words model. Another one is skip gram model. So in this continuous bag of uh, word model, wherein we have a set of words. Among that, you are going to project, and the output will be the word which will be guessed among all these words, and that is the output. That is called continuous bag of words. So in this, whatever the word which should be there, that will be guessed by this neural network, and that is the output. W of t will be the output of this continuous bag of word. Second one is skip gram model. Skip gram model, wherein we are going to have the input and we are going to see where it is going to fit. Okay, so the word and the surrounding information we are going to have in the skip gram model. So these are the two techniques in word to vector technique. Now, next technique what we are going to see is that is word to vector. We are going to see the next topic is text frequency analysis. Now, in this text frequency analysis, how we are going to teach the machine how to do natural processing. That means we are going to see the words. It is also called n-gram model. Suppose only one word at a time if we are taking, then it is called unigram model. If you are going to take 2 gram, two words, then it is called bigram model. If it is three words, then it is a trigram model, and so on. So we are going to teach the machine how many, what are the sequence of words and which are giving meaning for the which we can extract meaning from that text. Okay, suppose the machine wants to learn the following meaning of the sentence: I have lovely dog. Then we have to split. This will be splitted. If it is a unigram, then it is splitted as I have. I is one word. Yes. Then we have a lovely dog. So this is a unigram. Okay. So suppose if we have backgram, then we have I have, then have a, two words at a time will be clubbed. Okay. So I have a lovely dog. So these are the bags, grams which are formed in this text analysis. Now, so the next topic is semantic analysis. So the exact meaning or dictionary meaning you are going to find in the text. So actually semantic analysis is different from lexical analysis. As we might have seen in compilers, the first phase is lexical analysis, wherein we are going to have the tokens of the whatever the code we have. But here the semantic analysis is other to the meaning of the tokens. That in that sense it is different. So semantic analysis can be divided into two parts. One is studying the meaning of individual words and studying the combination of individual words. So how the individual words are meant, and how the combination of words are going to give a different meaning. So that is what the semantic analysis. For example, suppose God is great, or suppose if you say Ram is great. Suppose if you write Ram is great, whether the Ram who is God is great or the person who is named Ram is great. So that meaning should be extracted in semantic analysis. So the building blocks of semantic system are entities, concepts, relations, and predicates. Now, what are entities? Entities are the building blocks of the text or the objects which you are going to have. Then we are going to see the meaning with respect to these entities, that is called concept, and how these entities are related with other entities, that is called relations. So suppose uh, uh, Kaku is a bird. Kaku is a bird. Kaku is a entity. Bird is an entity. And how these Kaku and bird entities are related with the relationship is A. Okay. So this is a object orientation. What we think about different objects, how those are related. So that is what in the semantic analysis we are also seeing the relation between the objects, and also we are going to see how it can be represented with the predicates. So predicates, in the sense, it gives us some more information so that it can be represented in the knowledge base. So in knowledge inference engine, you are going to store that information by writing these information using predicates. So these are the building blocks of semantic system. Okay. Then there are some other representations also in semantic analysis. First order predicate logic, it is also called FOPL. Then semantic nets, wherein using some diagrams, we are going to show how these objects are related with each other. Then we have the scenario based representation, conceptual dependency, how the concepts are related with other objects that you're going to have. Then also it can be represented with the rule-based architecture. So these are different semantic analysis approaches. So rule-based in the sense how each, we are going to write a set of rules, and with respect to that, we are going to say whether it is matching to this rule or that rule, and so on. The rule base we are going to store, and thereby we are going to compare with these different sentences. And case grammar and conceptual graphs, and in a top-down fashion, we are going to represent the parse tree or the conceptual graphs, which consists of the entities, and it can be represented. Now, the question is how we do need this, how we represent this meaning. Okay, so using this linguistic elements, non-linguistic with the non-linguistic elements. So there are various techniques wherein the semantic analysis is quite vast theory which can be used for reasoning. Okay, and the next topic is web scraping. Suppose we are going to say the websites that contain large amount of information. Now most of the information is stored on the internet. Now we want to access this information, we want to access this, we have to automatically you have to download this information and process it, so that without going into that, we can get the information what is lying in the internet. Okay, so for that we are going to have this technique called web scraping. Okay, how we can access the large amount of data, and how we can scrap the data, which can help us to analyze the data. And so we are going to use one module, one library called Beautiful Soap. So that I would like to tell about that in my hands-on session now. And also how you are going to export the useful format, that we are going to see. So so let me start with my Jupyter notebook and explain about these things. Is it Jupyter notebook is seen, sir? Is the Jupyter notebook is shared? Is it shared?
Not visible.
Not visible.
Not.
Oh, 1 minute, sir. 1 minute. Is it visible, sir, now?
Yeah, visible.
Okay, sir. So these are the models. All of these are not required for all of these. We need to have these libraries which we are going to import. In Python, we are going to import for NLTK, import NLTK. I'm going to write. So then for regular expression, I'm going to import RE. Then for NumPy, for scientific calculations or array representation, I'm going to use NumPy. Then for this text processing, I'm going to have this GenSim. Then for machine learning, I'm going to use sklearn. And for creating the text format frames, we are going to have, and the data, for this we are going to have pandas. Then requesting from the information from the web, we are going to have URL-lib. Then we are going to import the warnings also. And the NLTK has a large corpus that we are going to import stop words from NLTK corpus. Means NLTK has all the stop words which are stored that we are going to import. Then we are going to import word tokenize. From NLTK tokenize, import word tokenize. Then we are going to use for TF-IDF word vectorizer. So we are going to have TF, we are going to import from sklearn, we are going to use this feature extraction of the text using this TF-IDF vectorizer. Then we are going to use this word to vec library from GenSim model. Then we are going to ignore these warnings. Then we are going to use this n-grams for the semantic analysis, and that is present in NLTK UTL. And then we are going to import this counter library from the collections for counting the number of words. Then we are going to have we are going to use the truncated SVD. SVD stands for single value decomposition. I will explain about this. Then we are going to have TF-IDF vectorizer and count vectorizer we are going to import. And then we are going to import this normalizer for pre-processing. And also we are going to import metrics from sklearn. And also we are going to use clustering, wherein k-means clustering and minimum batch means we are going to import from sklearn. And we are also scrapping from the web information. For that we are going to use beautiful soup. For that we are going to import BS4. BS stands for beautiful soap. Okay, so these are the modules. Why? So in the first cell, all the modules which are required, I have imported that. It is taking some time to run here. Since it is showing start, so it is taking some time. Should I go ahead, sir? So let us, yes. Is it visible, sir? So I'm going to assign a text, okay, a paragraph. Hi, I'm trying to explain about the current farmers' situation in India. The farmers are suffering a lot from natural calamities. And so some sentences I have stored, in this text, okay. And then I'm going to use this sentence tokenize, okay. So which is present in NLTK. So NLTK dot, the function name is sent tokenize, sent underscore tokenize, and text whatever the input I have typed here. And that information, the sentence information, I'm going to store it in data set. So in the data set, we are going to, when we display this, what all sentences I have stored is a list wherein the first sentence is hi, then second sentence is I am trying to explain about the current farmers' situation in India. Then third sentence is the farmers are suffering a lot from natural calamities. So these are the three sentences I'm having in my text. Now, when we after having this data set which we have created, or you can say it is a corpus which we have created just now. Now we want to we want to use a bag of word technique. Okay, so we want to create a vocabulary. What is vocabulary? The dictionary we want to create. So I'm going to create a dictionary. Word count is equal to a dictionary, empty dictionary. First, I'm going to assign it to empty dictionary. Now, for each data in the data set, I'm going to see the word. Okay, so the word all the words. Okay, all the words in this data, in each sentence in word data set, I'm going to take that word and store it in another list called words. So words will be having all the words which are there in that sentence. So for each sentence, in each sentence, so words is what? Each sentence. In each sentence, I want to see how many times that word has occurred. Okay, so if word is not in word count dot keys, that means if it is not a key, then I'm going to, if it is not present and I have found that, then I'm going to assign the word count as 1. Else I'm going to increment that word count. So like this, we are going to each word, how many times it is occurring in the sentence, that I'm going to have it in the word count, in the word count dictionary. So when I'm going to display this word count, let us see here. When I say word count, it is going to show me high appeared only once. Okay, dot has appeared twice in my corpus. I has appeared only once. I am appeared only once. Trying is appeared only once. Whereas farmers has appeared twice in the corpus, and so on. So the word count dictionary is going to show me each word and how many times that word has appeared in the dictionary. So this is how the feature extraction is done. And now I want to see how many features are present now. So when I want to see the features, means how many words, unique words are present in this bag of words, then I can say len of word count. So when I say len of word count, it is going to show me there are 21 different words which are present in this corpus. So len of word count, it is going to give you me 21. Okay. Now I want to see the scoring of words. Now I want to see how many in each word, how many this I want to generate the vector. I want to generate a vector. So I'm going to write x equals to empty list, and then for data in data set, the vector is equal to empty set, and for each word in a word count, that means word count is a dictionary. In the dictionary, if that word is present, if this key is present, then I'm going to say that if that word is present in this tokenized word, then I'm going to append this vector. So vector I'm going to append with this, and with 1. That means that word is present in that sentence. Else what I'm going to say, the word vector is appended with 0. That means this word is not present in that sentence. So this is the way we are going to create a vector, word vector. Okay. So, and this x is actually the empty list, and now I'm going to append this vector, whatever I have created with this iteration, whatever the word vector is created, that is appended with this x. X is a empty list. So I'm going to have the all the what are the sentences which we have, all those are present in x. Now this is a vector, but I want to represent using as a array. So for that I'm going to use numpy. So numpy, that is numpy is represented as np dot as array. Okay, np dot as array of x. So I'm going to represent that as an array. Now suppose I have represent that as an array. Now I want to see the shape. So how many sentences, how many words are there, and how many the columns are there in that. So features, we know that we have already calculated 21, and how many words are there that we are going to have in this. So it is going to represent as 63, 21. That means 63 rows are there and 21 columns are there. Now suppose if I want to see x of 0 is the first sentence. Now this sentence, in this I'm going to have two words and all others are 0. So it has only two uh, uh, information like hi, that is what hi and dot. My corpus is this hi and dot, so it is having hi and dot. So in the first place I'm going to have one for hi, and second for totally it has 21 features. Out of that, first two is the first sentence, first two is hi and dot, so all others are represented as 0. So in this fashion, suppose you want to see x of 1 or 2 or x of 20, you can represent each sentence the how it is represented in the vector form. Okay, now suppose if I say x, then the whole document, uh, uh, how many how many words where it is where the words are present in that dictionary with respect to the features which we have extracted, it is going to represent in this fashion. So it has created an array which is having 63 words and 21 features. So so that it is going to represent in this fashion. This dot means what? It is repeated, so on. You can say so on. Okay, like this it is so on. So it is going to represent in this fashion. Okay, but now this this is the way. Now this is ready for any machine learning algorithm to work on this bag of words. Okay, now it is ready. It is in a numeric format. Any statistical algorithm or a deep learning algorithm or neural network, you can implement on this data which has been processed in this bag of word. Okay, so in this format we have to represent. That is what we have done using this bag of word technique. Now, as we know that the previous document was having all the characters, okay, some of the characters which are not useful in which are not useful in which are not having more useful information like punctuation marks, I, was, in, all these are considered as stop words, and it is better to remove these stop words so that the size of the vector will be reduced and the processing will be faster. So the bag of words, the next what I am going to do is the bag of words after removing the stop words. So how we can do that? We have already imported stop words from NLTK library. So we are going to say set, okay, stop words equals to, we are going to assign stop words equals to set of stop words dot words, and English language we are going to take. So all the stop words in this which are present now, which are residing in this stop words. So we have imported from the NLTK library all the stop words which are presented in the language. Okay, now we want to remove these stop words in our corpus. Okay, so let us consider filtered words equals to empty list. Okay, so we have initialized filter words to empty list. Okay, then for W in word count, already we have the word count, and if word this W is not stop words, then we are going to append that. That means if it is not a stop word, then only we are going to append that to the filtered list, filtered word list. Okay, so that's what we are going to do. Filtered word list dot append of W. So all the words which are not stop words are now stored in the filtered word list, means it is an array. Okay, so we want to see what is the word count, and we want to display what is the word count and what is the filtered word. Now you see here, the word count was having how many times each word is appearing. That's what was shown here. And the second one is filtered word. Filtered words is not having, uh, uh, now you see here, filtered word is not having those stop words. Okay, so hi is there, dot is there. We can remove this dot also by appending this dot with the stop words. Okay, now you have only unique words. Okay, that is hi, dot, I, trying, okay, am, was, are, all these stop words are removed, okay, in the filter words. So this is the output of this. So the first one is telling the dictionary, which is having the word count, each word with how many times it has appeared in the sentence. And the second one is the filtered words, wherein only the unique words are represented in the list. Okay, so the word, now we want to see the what is the length of the word count. So length of the word count and length of the filtered words. Okay, and then we can see here the length of the word count is 21, whereas the length of the filtered word is 14. If the document is very large, it is a significant achievement over here. Like the filter words will have very less unique, very less words which can be processed in the text processing. Okay, so this is the output which is shown here. Okay, now next thing is what we are going to do. We are going to represent this information in how it is represented in this form. So we are going to create an array. Okay, X, okay, is a list. X is a list, is a empty list. Now for data in data set, we are going to create a vector, again the same procedure, word in vector field. Now, which if the word is present in that, okay, so we are going to represent in the vector as 1. If the word is not present in that cell, we are going to represent it as 0. We are going to append a vector with 0. Okay, and this vector is appended with X, and this X is now converted into array using this np dot as array of X. So it is going to create an array. Now suppose if you see what is the shape, that means what is the dimension of this X is 3 sentences are there and 14 different distinct words are there. So X dot shape will give you 3 rows and 14 columns. So this is what we have created after removal of this stop words. So we are going to have 3 sentences with 14 columns in that. And suppose if you say X of 0, it is going to tell you that the first sentence, okay, which is having first 2 elements are having I and dot, and all other rest of the elements in the vector are represented as 0, and so on. We can have this. Now suppose the whole document we want to see in a this word vector format, then X if you write, then it is going to show you all these 3 statements. Wherever the word is appearing, the respective word is appearing, it is going to show it as 1, and wherever that word is not present, the unique word is not present, it is represented as 0 in this list. So this is a 2-dimensional array wherein it is representing 2-dimensional array, and 3 rows and 14 features are there in this after the removal of stop words in the using bag of words technique. So that finishes the first technique, that is bag of word, how we are going to achieve and we are going to extract the features of the text. So this is one of the way of pre-processing. Then second one, we are going to see the TF-IDF. Okay, so in TF-IDF, we are going to use TF-IDF vectorizer. We are going to call this TF-IDF, and this is present in sklearn. So we have imported on the top TF-IDF vectorizer, and we are going to see that TF-IDF vectorizer is called, okay, and that object, that variable is created. Vectorizer is a variable. Now we want to fit all the data set we already have, the corpus which is having 3 statements which we already have, okay, and these we want to fit it. Okay, we want to see we want to create a TF-IDF score for each word in this document or in this corpus. So fit function is used for this. So vectorizer is the object dot the fit function followed by the argument, the corpus we are going to give it as an argument. Now we are going to print the all the features, the unique features what we have gathered, those features we want to display. So we are going to write print vectorizer dot get feature names. So you are going to call that. And then we want to see what are the vocabulary, what are the distinct words we have created using TF-IDF. So vocabulary we are going to create, and then we are going to display the vocabulary. That means the TF-IDF score we want to display. Here we are just displaying the unique words, whereas unique words TF-IDF score will be we want to display. And after that, also we want to display the IDF score, inverse document frequency. So inverse document frequency we want to create, and thereby we are going to generate, we are going to, we want to say what is the TF-IDF score we are going to have for that. And only those are the important rare words which are present in the document that can be used for analysis. So vector equals to vectorizer dot transform data set, and we want to display this vector dot to array. We are going to create an array out of it, and we are going to display the TF-IDF scores. Now let us take the same example, whatever we have taken. So our first print will tell you the feature names. So about, am, are, because I said that a bag of words will not have the order is not important. It is just a bag of words. So all the unique words which are now, all the distinct words which we are having in this document, which is extracted as feature, or it is also called feature engineering, and those are listed here. Okay, using this fit function, it has generated. Next one is we are going to have the vocabulary. So how many times, at which location, what is the position we are going to have in this, that it is going to display in this vocabulary. Okay. Then we are going to have IDF scores. So IDF scores of each distinct feature that is calculated and that is displayed over here. Now TF-IDF, you see here, there are significant words which are present using, now all others will be almost, this TF-IDF score will be within 0 to 1. So some of the TF-IDF scores are 0.23 to 31 and so on. So we can see significant TF-IDF scores which are present in this document that can be taken, and those features can be used for text analysis purpose. So this is about TF-IDF. Okay, the next one is word to vector. Word to vector technique, wherein we are going to, let us consider, we have one large text which I have downloaded from internet. This is a file. The name of the file is alice.text, and I'm reading in read mode. I'm reading it. So, and whatever is read, which will be stored in sample. So this text file is stored in sample. Now I want to read that. So I'm going to write, I have opened this. This is just a file pointer, and then I'm opening that in read mode, and then I'm going to read that file. So whatever is read, which will be stored in yes. Now in this text file, I want to replace all the new line characters, because it is a large document, and I want to replace all these new line characters with a blank space. So that's what I have done here. So yes dot replace, the new line is replaced with a blank space. Okay, so this is the replace string method I have used here. And then list one, I'm going to create an empty list, and then I'm going to have, I'm going to run through this sentence. Okay, so I is the variable in NLTK sentence tokenize of whatever the F which we have created, that we are going to have in F, and in this we are going to create the words. Again, the next we are going to create one temporary list, and then we are going to have J is a running variable which runs through this uh, sentence, and we are going to form the tokens out of it. And those tokens, okay, what in this case, now in the first case it is going to have the sentence tokenized, and in the second case it is going to form the word tokenized. In this word tokenized, each word is converted into lowercase, because it is not necessary for me to know what is the case. Okay, I in capital letter or I in lowercase letter, it means the same thing for the machine learning algorithm. So I have to I'm going to, because capital I and small I will be having different meaning, because if I is appearing in as a first statement, I will be in capital. Somewhere if it is there in lowercase, all these things should be in lowercase letters. All the words should be converted into lowercase letter, and each word is converted into lowercase letter. That is what we are doing, J dot lower. So it is converted into lowercase letter, and that lowercase word we are going to store it in the temp. Okay, and this temp, now we are going to append it to list. Now list will be having all the words which are in lowercase letters. Okay, and after this, after appending this, I'm going to use this gensim package for uh, what GemSim package, wherein this which has this word to vec library. Okay, so model 1 equals to gensim dot models dot word to vec list 1. Okay, list 1 is the argument which you have already created. It is having the list of all the words which are present in the document, and then we are going to have a minimum count, the minimum number of words which we're going to have consider, and the maximum size we are going to take it as 100. And how many words at a time we are going to take into account, a window, like how many words in a particular corpus we are going to take, that window we are going to take it as 5 here. And then we want to see the similarity, because as we know that word to vector wherein the semantic meaning will be preserved. Now we want to see what is the relation between two words uh, in a particular document. Suppose in this alias.txt we have the alias and also wonderland. How this alias and wonderland are related in this document, that we want to see. So for that, we are going to use a similarity function. So model 1 dot similarity, wherein it is going to find Alice and Wonderland, how many times these are appearing in the document or in the corpus. That is continuous bag of words. We are going to use this continuous bag of words technique, wherein how many times this Alice and Wonderland are appearing together, and what is the relation between that which will be displayed. Similarly, for Alice and machines, it is this corpus is also having Alice and machines. How much relation is present in Alice and machines, that we want to see. So model 1 dot similarity Alice and machines, and it is going to display what is the relationship between Alice and machines. So it is going to show me that very less uh, times the Alice and Wonderland has appeared, and also the Alice and machines has appeared in the document. So that means only 0.2 times this Alice and Wonderland has appeared, and 0.19 times this Alice and machines has appeared. Okay, this is about the continuous bag of word document. Now similarly for the we want to see the word to vec model for the script gram model. In the script gram model, we are going to find a particular what is the similarity between the words. Again, we are using this model also. When we are going to use script gram model, we have to write SG. SG stands for script gram model. Okay, so SG equals to 1. Herein, we are going to use a SIBO method, so we have not written, but all other things are same. So model 2 will be added with one more parameter, that is script gram model equals to 1. If script gram model is equal to 0 means it is a SIBO model. And here also we are going to see the difference between these two, the similarity between these two words in a document. So similar results only we have got after this. Okay, if we have some major difference, these all the times these words are appearing together, then the frequency of these togetherness of those words will be more. Okay, so this is an example for semantic analysis. Okay, then next comes the text frequency analysis. Now let me take, I have taken one example here. Now I'm going to assign text equals to, I am working as a associate professor in Reva University, and Reva University is located in Bangalore, and it is an independent university. So these are the three sentences I'm going to embed in this text corpus. And now I want to do this n-gram, like how we are going to have this n-gram. So we are going to import NLTK, import n-grams. So n-grams is present, this library is present in the NLTK module. And then we are going to tokenize this corpus. So NLTK word underscore tokenize of this text. So it is going to convert this text, and we are going to have this text, we are going to have this words in this token. Okay, and I have not printed here. You can print also that what all words which are present in this corpus. Then I want to create bigrams, 2 words at a time. So sometimes it is very important that how many bigrams we are going to have, how many times that particular word is appearing together. That also we want to count. So for that, we bigrams are very helpful. So we are going to use this n-grams, and the argument is token, comma 2. If it is bigrams, it is 2. If it is trigram, it is 3. If it is 4 grams, 4 words together, then it is 4. So for bigrams, I have taken it as 2. Okay, so that I'm going to, and I'm also want to display how many times that bigram is repeated. So I'm going to display that. Okay, so counter function is used, counter of bigrams, how many times that bigram is appearing in the document. So the result is it is going to show Reva University, which has appeared twice in my document. So I have one Reva University, another Reva University, which is the independent university. Reva University is located in Bangalore. So twice this these 2 words bigrams are repeated. So you are going to have a counter as 2. So similarly, I am is one tuple which is created, and it has appeared only once. I am working is also once, and so on. So these are the bigrams which are present in this text document. So like this, we can create bigrams or trigrams, and you can analyze the data depending on your application, how the information is repeated in your, or how the information is processed, how the information is, the characteristics of this information which is present in the corpus, that we can see. Okay, so this is how we are going to create the grams in text analysis. Okay, then we are going to see the another semantic analysis. Let us take another example, the same example I'm going to take, example equals to, and then I'm going to create, I want to remove the stop words also, and I'm going to use a count vectorizer for that. So vectorizer I'm going to create, and I'm going to remove the stop words in this. Okay, so for semantic analysis, and then I'm going to create the fit function. I'm going to see what are the unique words which are present, and those are stored in DTM. So DTM is a frame I'm going to create. So PD dot data frame. Okay, I'm going to create a frame, and this I'm going to convert into array. Okay, and the index is example. So the name of the table is example, columns vectorizer get features, and I can see here, you can see here All these features are lower automatically using this vectorizer. It is automatically converted into lowercase letters. All these features are in lowercase letters, and unique features are there on the lowercase letter, and the sentences are appearing on the in this vector. Okay, so it has two sentences. Okay, and wherever this word is appearing, it is going to have one, and wherever the word is not having that sentence, then it is going to write it as 0. So in this way, we can create a word to vector using vectorizer, count vectorizer. We can create a count using this. We can create a vector. Now, in this, we want to access only the features, only the feature names. Okay, so we can say that vectorizer dot get feature names. So it is going to show me the unique words in this document: associate, Bangalore, independent, India, located, professor, Reva University, and working. These are the features of this document. Similarly, so this is how we can get the features in this document, and we can process that information. Okay, so the next one, what we are going to see is the clustering method. So all these only we have seen how we are going to process the information, and we can create a document vector which is representing in the, so that it can be used. Now we want to process this. Let us consider we want to create a cluster out of it. So I'm going to use K-means clustering, because I want to create a clusters wherein it is having similar information as cluster. So in this case, I'm going to use clustering method. Okay, so let us take an example. Example equal to there are some words here. Machine learning is super fun. This is the first element in this first element in this list. Python is super cool. Statistic is cool too. Data science is fun, and Python is great fun for machine learning. Great for machine learning, and I like football, and football is great to watch. Okay, so these are the sentences which I have stored in this list. Example. Now I want to remove the using count vectorizer. I want to remove the uh, stop words, as well as I want to create a data frame out of it. So so count vectorizer, it is going to create this, and then vectorizer dot fit function, which will transform this in a table, in a frame, in a list, and that list we want to generate a data frame, and we want to convert it into 2 array. Okay, and we want to display on the column all the unique features, and we want to display only 10 lines. Head means head of 10 means only 10 sentences we want to display. So this is how we are going to have. Now when we run this, it is going to show me uh, all the features which are now on the column, and all the sentences, what all sentences I'm having, those are displayed as rows. Okay, and wherever you can find these words, it is going to represent as one, and all others, since fun is there, this fun will be having one. In the cell, in that cell, it is having one. Learning, it has one, and so on. So wherever that word is appearing, it is going to represent it as 0, 1, and if it is not present, it is going to represent it as 0. So in this fashion, it has been represented. Okay. Now you want to see what are the these. So you can write vectorizer dot features name. So the features, the unique features which will be displayed. Also, we want to see what is the type of this data type. That also you can see it is a document data type, what we are going to see. Now, similarly, we want to use latent semantic analysis. So for that, we are going to see this truncated SVD. There is one technique wherein we are going to create uh, uh, in uh, a table, okay, a table wherein uh, we are going to use singular value decomposition. Singular value decomposition in the sense we are going to create the whatever the matrix which is given into three components. Okay, so in that we are going to see the first one as a V U transpose. So in that fashion, it will be generated, and the first one which tells about the magnitude and which are the principal components. It is going to create a principal components and which are the significant this truncated SVD which will create which will see which are the principal components in this text, and that it is going to thereby it is going to extract the features. So for that reason we are going to use this truncated SVD. Okay, and in this we are going to LSA.fit transform. So we are going to apply this method, and then we are going to normalize this. Okay, and now you see this data frame how it is going to it has suppose we are interested in two components. Okay, so depends on how many components you want. Only two components we want to have, so we are going to say component 1 and component 2, and how many what is the score of that will be represented in this in component. What is the significance of this? Okay, so that is the word cool in the component 1. So which components are important, only those will be taken into consideration in truncated SVD. Now using this component 1, the we have different components. Among that we have taken only two components, and thereby the score of those are written here. And after so in this fashion it is be written, and now we want to see we want to apply this LSA on this, and it is going to show you the different significance of each words in these components. Okay, and then we want to see the principal components. Okay, so the first principal components and the second principal component. To display that, we are going to use matplotlib. Okay, so import matplotlib dot pyplot as PLT. So short name for matplotlib, we are going to have PLT, and we are going to have a figure function which is called. Then we are going to have a scatter plot, x and y axis. Okay, and we are going to have the x label as first component, and the second component is a y label, and then we are going to print these components on this space in this LSA principal components space. We are going to display on this in this area. So what is the significance of these points in the principal component analysis that we are going to understand here. So what are the principal component, each components of the significance of each component, which you are going to plot with the x and y axis. Now suppose we have these components. Now we want to see how far these components are related with other components. So we can write the relation between these components by plotting by plotting the graph. Okay, so it is going to represent the principal component in this fashion. Okay, and similarly we want to find the similarity of these components which we are going to have, and thereby the correlation matrix it is going to create. So we are going to have the sentences, and we are the sentences on the x-axis and sentences on the y-axis, and we want to find the relation between these sentences. As we can note down here, the sentence 1 and the sentence 1 is related with itself as 1. So all the the components which are on the diagonal, all will be 1, and how far each sentence is related with another sentence, that we can get using this LSA method. So you can say Python is super cool, is related with machine learning is super fun with 66%. It is related. So like that we can see the relation between now statistics is cool too, which is related with Python is super cool 90%. Okay, so that is the relation, the similarity index we are going to display here. So it is going to show, and thereby in this case each sentence is related to itself. So on the principal diagonal you can have all these are ones, and all other how these, why this is very important, because we want to see how a particular document is related with other documents. So one document in one column we are going to take, another document we are going to take on another row, and thereby we are going to compare and see how much we can analyze the document, and seeing that whether this technique can be used in plagiarism checking also, how it is um, the same document, or how much it is far away from this. All this analysis we can do using this technique. Okay, so the last topic what I would like to talk about, how you can scrap the website. Okay, so for this we are going to have we are going to import request. Okay, so we are going to import this beautiful soup, which is we are going to import this beautiful soup, and this is comma separated values. This also we are going to import, and let us take an argument URL equals to the website, whatever the, let us I'm interested in inspirational quotes. What are the inspirational quotes? That website I have quoted in double quotes, and then I'm going to give that I'm going to connect to that website using this request. Okay, so I'm getting connected with this. I'm just telling that to which website I want to that name of the website. I'm going to store it in URL, and I'm going to connect using this request to connect to this URL. So R is the connection which you're going to form, and then I'm going to use this beautiful soup to see the contents of that website. So I'm going to use this r.content, and that object, whatever the return value, which is the text information, I'm going to have in soup. Okay, so I'm going to have this text information in the soup. Now I want to see the what all quotes are present in this. So I'm going to just write quote equal to empty list. Okay, and each I'm going to traverse in this website, and I'm going to see what all interesting inspirational quotes I'm going to have. Okay, so I'm going to create a table here, and since soup.find, and as you know that this is all these websites will be having HTML tags. So I'm going to take into dive. Okay, and all the quotes, the ID is all quotes I'm going to take, and then I'm going to access we should see in that website at what particular location we are going to have this class column, and in that website I'm going to take into all these features, and then I'm going to create a dictionary code. Okay, and a theme, and followed by whatever the information I'm going to get here, and the theme as well as the URL I want to display, then the all other information, the lines, and the author, who is the author, all this information I want to get in that code. Okay, and that I'm going to append it to quotes. Okay, and the file name is inspirational quotes.csv, and then this file name I'm going to store all these quotes in a file called inspirational quotes.csv. So so I'm going to open that in write mode, and what all quotes I'm going to have, that I'm going to store it in this file. So w.write header, header will be written, then quotes, each quote will be written, w.write row of quotes, then print that code. And in this fashion, I'm going to get all these codes which are there in the website. So this is way it is going to show me all the codes which are present in that website. See here, we can see here some codes that is uh, give me 6 hours to chop down a tree. I will spend first 4 hours for sharpening the axe. Okay, so author name, all this information will be accessed from that internet. Second one is first I prepare, then I have faith. Okay, and some other author, then another. Quote which I have accessed here. We cannot always build the future for our youth, but we can build the youth for the future. So inspirational quotes which can be accessed using beautiful soup. Okay, so this is one way, and this all information will be stored in that is what is that CSV file, inspirational quotes.csv. I will show you how it is been stored. Okay, so now I'm just accessing the information in this thing, like uh, again the writer open only I want to write what all names of the authors. Okay, now I want to show you only the names of the authors I want to access. So that file I'm going to open in write mode. I want to open in write mode. So I'm going to write in the CSV file, and the row, the name and the link I'm going to write in that file. So f dot write row, name and link, and then I'm going to have a page. Okay, which is pages, how many pages we are going to have. So I'm going to have the empty list now, and then I is ranging between, range function is used from 1 to 4. Okay, and then the URL, this URL I'm going to take into account, and this page I'm going to access, and then I'm going to use this beautiful soup for, I'm going to use HTML parser to access this information. And then I'm going to see what is the class, and what is the text in that form I'm going to have. And then I'm going to access all the names, and it is going to show me who all are the authors which have written these different information into that text. So this is what is displayed here. Okay, so another thing is I want to see only the 10 only the 5 authors and their respective links wherein they have stored the information. So see here, data.head, if I have written, then the name of the author followed by his link, which will be displayed. So in this fashion, the information will be stored in CSV file, and we can display that information from the CSV file. So any, let me take, this is how using beautiful soup we can access the website, and we can access the information which we need for processing, because we can generate corpus using beautiful soup, and we can process on that. We can this beautiful soup is used in recommendation systems and sentiment analysis and so on. So that completes my demo on text analysis. And 1 minute. Okay, so there are a few things which you have to take into account. So we have to build a corpus. First, the corpus is taken as an input. Then we have to clean the text. Then we have to form the tokenization. We are going to form the tokens. And then we have to remove the stop words from that corpus. And then uh, we have to normalize the text, that is using stemming and lemmatization. Then we have to do feature engineering, that is feature extraction. So after feature extraction, we are going to analyze the text. And for analyzing, again, we have different ways. We can use machine learning. We can explore the word, how many times a particular word is appearing. So different tech analysis we can do. We can group the information. We can do classification of the documents. We can cluster the similar information. We can use naive-Bayes classification algorithm for that, or you can use the LSTM algorithm on these features. Okay, so different different algorithms can be can be work can you can work with different algorithms to analyze the text. So that completes my demo. Uh, is there any questions are there? Can I hear any questions?
Any questions from the participants? One or two participants can raise the questions. Shilpali Pankaj having some question.
Sir.
Madam,
Yes, sir.
Shilpali is having some question.
Yes, sir. Can ask, sir.
Please raise the question. Rather than putting the message, please raise the question. Sheila Jawale. Madam, Sheila madam.
Hello, sir.
Yes, you are raising some question.
No, sir. Thank you.
I'll be sharing this code with the organization. You can go through this code also. Sir, I'll be sending this code so that they can work out with this.
Yeah, you send the code, madam. So in fact, that is helpful to the participants. In turn, I will share them also.
Yes, sir.
I think some participants may raise some questions. That's what I'm just waiting for a minute.
Okay, sir.
And feedback, in fact, participants, it is shared in the chat box. Zoom chat box only, it is shared for all the sessions. Please fill the form carefully. Fill the feedback form carefully. So we'll be holding for another 1 minute. So already it is shared. I think participants are not raising any questions. We have shared the feedback form. So tomorrow again, we are starting day 3 session that is on blockchain and smart contract concepts is there. So in the morning session, that is our professor K.Laksminarayana sir is going to take the session. So please all of you join the time 15 minutes earlier. So thank you, madam. Thank you very
Thank you,
much for
sir.
your knowledgeable and skilled, the as well as a very important time you have taken out and given the time for us to spend to share your valuable resources for us.
My
So I
pleasure.
thank especially to Dr. Lakshmi B. Rananware, School of Computing and Information Technology, on the topic of NLP for Indian languages demonstration given by for the day 2 session 2. So once again, thank you, madam. And the participants, we are winding the session, and will tomorrow we'll go with the day 3 session.
Thank you, sir. Thank you, sir.